Algebra II students, today we're going to review the idea of graphing inequalities. So you can see in front of you, we have a few inequality signs just to refresh our brain. So you see the less than sign, which looks like more like an L shape. We see a greater than sign, which is pointed to the right. When you have the line underneath, that stands for less than or equal to. When you have the line underneath of the right-hand symbol, that's greater than or equal to, or you might have a slash through your equal sign, which stands for not equal to. Now, before we get to inequalities, we're going to review our linear equations. So when we're graphing a linear equation, we're going to start with the b. Now, that is assuming our graph is in slope-intercept form, that mx plus b idea. So we're going to start with b, which is our y-intercept, and I'll give you a little reminder, we're starting with b for the beginning of our graph. So we're going to plot out our y-intercept, and then we're going to go to our m next for moving our points. That's going to find us our second point, and so forth. So if you look at this example I have typed down here for you, it is y equals 2/3 x minus 1. So in this example, our b is -1. So at the beginning, we're going to plot that -1 point. Then we're going to move to our slope, which is 2/3. Since it's positive 2/3, we can either move up 2 and over 3, or we could also move 2 negative movements down 2 and to the left 3. Those 2 negative movements will make a positive slope for us. Then we connect those dots, and that gives us our linear equation. So let's look at 2 more examples in linear format. So again, we're going to start with the b of -4. So I'm going to plot that on my y-axis because that's my y-intercept. I'm going to use a slope of +3, +5. So I'm going to move rise 3, run 5. Or I can go down 3 and to the left 5. All right, and that's going to give us our linear equation. All right, one more example of a linear equation is -1/3 x plus 2. So we're going to plot or begin at +2 on our y-axis with our y-intercept. And then we're going to move, this time since we have a negative slope, I'm going to move 1 negative movement. So I'm going to move down 1 and right 3. Or if I choose to move up first, I can move up and left 3, giving us a linear equation with a negative slope. All right, now, how does this work with an inequality? Well, the graphing portion is going to work almost identical. It's when we connect the points that our values or our graph is going to look a little different. So the first thing I'm going to do is you can see that this doesn't look anything like y equals mx plus b. So the first thing I'm going to do is put into slope-intercept form. And you should do this with me. So I'm going to solve for y. So I'm going to take that x to the other side, and I'm going to divide both sides by -2. When I do it to the right side, I have to do it to everything on the right side. Now, we'll remember our rules for inequalities. When we divide by a negative, we're going to have to switch that inequality sign. Now I'll do the math on the right. -1x divided by -2 is a +1/2 x. And 4 divided by -2 becomes -2. So even though we don't have an equal sign in our equation because it's an inequality, we're going to graph it with b the beginning again. So I'm going to plot -2 on the y-axis, and I'm going to use a slope of positive 1/2, up 1 over 2, up 1 over 2, or again, I can go down to the left. Now, so up to this point, I do everything the same as an equation. What I'm going to do differently, because I'm not including the values on this line, this is going to become an imaginary boundary. So I'm going to actually connect this with a dashed line because I don't want any values on this line because all of my y values are greater than. So now I have to look at my y-axis from this boundary line. And I look at the y values that are greater because this says y is greater than this boundary line. So the y values that would be greater would be above it, all of these values. Now that means it can include anything up here. So what I'm going to do is I'm going to add a shaded region, and I'm going to shade everything that falls above this boundary line. And of course it even goes beyond that coordinate graph that I have here. And that's how you graph an inequality. Let's look at another example. So my second example is 2x plus 5y is less than or equal to 10. So again, I'm going to start by putting that into slope-intercept form. I'm going to subtract 2x and then divide everything by 5. I don't have to flip my inequality sign this time because I didn't divide by a negative. But this is going to result in negative 2/5 x plus 2. Start at the beginning with a positive 2, and I'm going to move down 2 over 5, 3, 4, 5, or up to 1, 2, 3, 4, 5 to the left. Now this time, because this is a graph that's going to show less than or equal to, it's going to add that equality portion. So this time I'm going to graph a solid line. But because it's including all values less than this line, all y values less than this line, I'm going to look at my y-axis. And if I look at my point on my y-axis, the point above it would be 3, the point below it would be 1, so I would want to shade everything below it because that's where we are less. So this becomes our shaded region. So any value inside of this shaded region will work. Now, if you're ever not sure if you shaded in the right place, what you could do is pick any point in that shaded region. So I'm going to pick a nice easy point. I'm going to pick the origin. You don't have to pick the origin. And I'm going to plug it back in here, and I'm going to see if it satisfies my inequality. So I have 2 times 0 plus 5 times 0. Well, that's all going to turn into 0. And 0 is indeed less than or equal to 0. So I did shade in the correct area. All right, so let's use this in a real life problem. So it says one tutoring company advertises that it specializes in helping students who have a combined score on the SAT that is 900 or less. Write an inequality to describe the combined scores of students who are prospective tutoring clients. Let X represent the verbal. There's 2 parts to the SAT. So you have the verbal portion, which is our X, and you have the math score, which is going to be represented by Y. Now, when you get your SAT scores, you'll know that you're going to have to add the verbal and the math together. So in our instance, that's going to be X plus Y. But the tutoring company says that you can only go to the tutoring if you have a score that is less than 900. So, or equal to. That is 900 or less. So here's our inequality. Now, if I need to graph this, once again, I'm going to solve for y. So that's going to give me y equals less than or equal to negative x plus 900. Now obviously when you look over here at my coordinate plane, I don't have 900 values to put on there. So what I'm going to do is I'm going to change the value of my graph, and instead of counting by ones, I'm going to count by 100s. I'm going to do that on the x and the y-axis. Okay, so I'm not going to put them on there, all on there. So I'm going to start at the beginning, and I'm going to find 900. So I have 1, 2, 3, 4, 5, 6, 7, 8, 900. And I'm going to have a slope of -1. So since I counted by 100s in both areas, I can go down 1 over 1. All right, now, one other thing I need to account for, you can see that I don't have a whole coordinate plane, and that's because I can't get less than a verbal score or a math score of 0. So I also am going to include the boundary lines. X is greater than 0 or equal to 0, and y is greater than or equal to 0. So that's going to be the axes here. Since it's including 900, it's going to be a solid line, and since our y values have to be less, our shading is going to happen in that triangle. So it's below the y is less than or equal to -x plus 900 line, but it's above these two axes. So this is our graph. Now it's going to ask, does a student with a verbal score of 480 and a math score of 410 fit into the tutoring company's guidelines? So I'm going to go back to that graph, and I'm going to look up 480 for verbal and 410 for math. Now I can do this algebraically, or I can do it using the graph. The graph would show me 1, 2, 3, 4, almost to 5 on the x-axis, and then I need to get to 400 on the y. So it looks like we're just going to be eligible. We're just going to be in that shaded region. Another way I can do this is really kind of add those two together and make sure that we fall into that less than or equal to 900 category, which is about 890. So to answer their question, yes, they would qualify for tutoring. Okay, so that concludes our lesson. I'm going to add this assignment onto Google Classroom for you to try, and we will talk about the questions tomorrow. Have a nice day.